Hello to all, and welcome to the joint Zendy and IntechOpen webinar, Emerging Technologies Partnering for Accessibility, Discoverability, and Sustainable Future. My name is Victoria Žgela. I'm Head of Editorial Development at IntechOpen. I would like to give a special thanks to today's panelists. May I add, it is a pleasure to have an all-female panel of experts, I would say, women in science and women in business. We will hear today from Professor Tatiana Morozyuk from TU Berlin, who will present a hands-on case of research on one of emerging technologies in energy engineering and sustainability, goal behind that research. She will be joined by Dr. Jo Haberman, who will present her work on Africa Archive in the context of securing discoverability and accessibility of research. And last, we will hear from Monica Chinsami from Zendy, a part of Knowledge E, who will present their work in achieving equitable access to the published research. I would like to use this opportunity to give a special hello to Ms. Sara Crowley-Vigneault from Zendy, who unfortunately couldn't join the webinar because of her illness. May I add that IntechOpen and Knowledge E, as signatories to the UN's SDG Publishers Compact initiative, are committed to promoting the content that advocates the themes represented through all 17 Sustainable Development Goals. And this webinar is part of these activities where we want to highlight the research and work that contributes to achieving the overall sustainability goal and that addresses several SDGs in particular. I'm also glad that we have managed to gather a group of extraordinary speakers that wrap up the scholarly communication landscape from its beginning, that is a development of idea that is translated into research and into a real-world scenario, distributing that very same research in its either developmental phase or as the ultimate result in a form of a published work, while at the same time securing the discoverability and maximizing its potential. Before we start with the talks, may I just add that you're free to pose questions to our panelists in the Q&A section. We will try to answer them live. So, without further ado, I would like to present Professor Tatiana Morozyuk, who is a long-term IntechOpen editor and author. I would like to say a supporter of open access, open science. She is head of the exergy-based methods for refrigeration systems department and the director of the Institute of Energy Engineering at TU Berlin, Germany. And Tatiana is the first female recipient of the James Harry Potter Gold Medal from the American Society of Mechanical Engineers for outstanding and innovative contributions to the science of theoretical and applied thermodynamics.
Thank you very much for the introduction, and thank you very much for this possibility for me to participate in the webinar and give the participants, mainly of course for young participants, a view about emerging technologies that are supposed to be used and appreciated to be used for energy sector. Here in this slide, there is only definition of what means emerging technologies. In energy sector, we will refer to innovative and developing technologies in related to all applications in energy sector that can have potentially significant impact to all parts of energy sector, means generation of electrical energy distribution and also consumption. Mainly we will focus on electrical energy, but of course energy sector, it is not only electricity, it is also heat generation, and now we have synergy with chemical plants. It is also some chemical substances generation. It is also belongs to emerging technologies, and briefly I will cover today all these topics. At present, energy sector is in the phase of transition. You know what means transition. It is from the conventional technologies, mainly focus on fossil fuels, to the new, all new possible options. So when we discuss about emerging technologies, it's better always to refer to technology readiness level. It is quite old as a scale for Europe, for European development. It is from 1 to 9, but not very often people discuss it about so-called TRL level. But for us, it's very important to mention that all emerging technologies that we will today discuss, and in general we will discuss, it is between level 4 and 7, because everything which is below 4, it is level of experiment, it is laboratory, difficult to discuss about even small scale application, and 8 to 9, it's already fully industrial technologies with small or large scale application, depends on. So therefore, one more time, we will discuss about technologies beyond to the level between 4 and 7. So we have right part of this slide, we can see entire energy sector and divide it into 3 groups. First, it is conversion of primary energy through energy conversion process to energy carriers. It can be fuels, can be electricity, can be secondary fuels. For example, hydrogen belongs to the category of secondary energy carrier, the same as diesel fuel, as gasoline, and so on. After that, we have transportation and distribution of energy. As you can see, it is not only electricity, but it is also can be chemical substances and fuel. And finally, we are with final energy consumption. Final energy consumption, all of us were consumers, regardless if it is for residential use or for our business purposes. All of us are consumers. Therefore, just for simplification of discussion, let me start with the emerging technologies in final energy consumption to understand better what is happening with the generation. What about energy consumption? Let us look to this very interesting, colorful diagram, how different technologies were developed, I mean, with the time development, and how many people, percentage of the population got access to these technologies. As you can see, for example, with TV, I will not take electricity and airplane, telephone, because it is very old technologies, but at least with TV and with personal computers and so on, at least require 10-15 years that these technologies came to the mass market, so that many people will have access to these technologies. But these technologies are based on electricity. It means that power sector, electrical generation sector, had at least 10-15 years to adjust, to be prepared for more electricity consumption because of new technologies. But look what happened with internet, and particularly with digitalization. Digitalization concept just was developed and immediately was already accessible by many people. And during 3-5 years, we cannot make the decision about new power plants and how much energy, electrical energy, we need to generate. In general, all these developments in digitalization belongs to category of e-mobility. So e-mobility, it is not only electrical cars, it is also smartphones, all sensors, so everything which is related to the word smart that now we are mention. And usually people mention the period of time between 2008 and 2018 as decade of e-mobility. So 10 years ago, we had no idea what is it, smartphones, I mean 2008 and 2018, already almost each person had smartphone and access to the internet. Also, the same applied to the levels of industry. As you know, now we're discussing about industries 4.0. It is cyber physical systems fully related to the control signals and so on. So all these technologies are required electricity. So it means that we need to have very stable supply of electricity, reliable, and also in amount that is required not for our everyday life with smartphones, with TV and so on at home, but also for industry. Next slide, please. Thank you. So now we will discuss about the distribution between energy producer and energy consumer. There is the energy distribution. Before, people only discussed about the distribution of electrical energy through grid, but now more and more we need to discuss about gas distribution network. Before it also exists, of course, but it was not so much linked to other industries, and also thermal distribution, because we know different heating systems and even different cooling systems, for example, in the Middle East, when they require more air conditioning than, of course, than heating. Therefore, approximately 10 years ago came the idea to have a statement and the definition of smart grids. So smart grid, it is not electrical grid, it is also can be smart thermal grid and also smart gas grid. So it means that under smart, we should keep in mind that possibility of combination of these grids with supplier and with user of corresponding energy carrier, and also synergy between grids and between supplier and users, and all these smart stuff associated, of course, with energy consumption for the sensors, for the distribution of information, and of course, finally, everything will be linked to cybersecurity and the reliability of distribution information in order to make all these grids smart. It is distribution. Now, next slide, please. We will discuss about energy so electrical energy generation, because electrical energy is very important for us, for each spheres of our activities. Let us assume that we have electrical energy. Somehow it is generated. And what we can say about electrical energy? Electrical energy itself, it is clean, flexible, secure, and reliable form of energy. This is correct. If we have electrical energy itself without discussion how to produce it. Electrical energy can be easily converted to any other form of energy with very high efficiency. Any form of primary energy, if we will look backwards to the this complex schematic that I showed a few slides before, any form of primary energy can be converted to electricity. And actually, nuclear energy and renewable energy in large scale can be converted only to electricity, because using nuclear energy, we're not allowed to distribute heat because of risk of radiation, and renewable energy, for example, hydropower or wind energy, we cannot generate any other sort of energy except electrical energy. With sun energy, we have different options. Also, if we have electrical energy, we can produce thermal energy at high temperatures. We will not discuss how useful is it or how expensive is it, but technically it is possible. And also, if we have electrical energy, we can have much more accurate control and control strategy for the for all power generation system and all power consumption system. And of course, environmental impact through because of electricity generation. Usually, the higher is the unit, the lower is the environmental impact. And this is a well-known phenomena that if large capacity systems, of course, much more efficient and less environmentally, so more environmentally friendly, better to say like that, per unit of generated electricity, that small and local systems. So please, next slide. Positive aspects I already mentioned. In this slide, you can find all these positive aspects again to follow, but we also have negative aspects. Always electrical energy is expensive. It can be very expensive. For example, in Germany, it is country with the most expensive electricity overall the world, one of these countries. And in any other countries, electricity is always relative expensive. Efficiency of electrical generation is still relatively low, and not because we are not advanced. There are some thermodynamic limitations, and we cannot overcome these limitations because of simply its physical processes. And really very big negative aspect, storage of electrical energy in large capacities, in industrial capacities. Storage of electrical energy in small batteries, this is well known for us. It is well developed and with very good effectiveness, but for large capacity, up to now, it is not economically feasible. And of course, any of technologies that can help us to make it economically feasible should be not only developed, but also should be advanced. And also problems, I already mentioned several problems related to electrical generation sector, but now I will summarize these problems. That decision to build a new power plant requires time. And if we have these very fast developing technologies that require electricity, and we cannot unfortunately predict when these technologies will come and how much electricity we will need to generate to fulfill these technologies. Not easy to estimate future demand of electrical power, and up to now we cannot see any of perspective to decrease electrical demand. Of course, electrical prices for electricity should support all these developments, and as I already mentioned, now we have more and more new technologies that purely depends on electricity, not depends on any other forms of energy. Next slide, please. So we have very interesting diagram developed by International Energy Agency, and of course it is with prognosis. Diagram was created shortly before pandemic time. And energy saving, if it is energy saving, automatically it is reduction of CO2 emissions and all other emissions associated with electrical generation. The largest contributor which technology can help us to save energy and also reduce emissions, it is technology switching. It means that if we will develop a new technology or advanced well-known technologies to the large-scale application, this is our way how to decrease primary energy consumption. And exactly these technologies are associated with the world emerging technologies. So please, next slide. Thank you. recently published World Energy Outlook. I think it was published at the end of October 2023. There are very interesting three prognoses in the consumption of primary energy. So it means that energy that's applied to power systems to generate finally electrical energy. We have one scenario that is mentioned that now annual growth in primary energy consumption, it is only 0.7 compared to the time before pandemic, it was 1.5% or 1.7%. Of course, depends on the scenario. One scenario say that it is almost flattened energy primary energy demand, which is, by my opinion, fantastic achievement. And there is even one scenario that showing that we have negative growth. This best situation cannot be, of course, that we have negative growth. So it means that we will generate more electricity, we will fulfill all electricity consumption, but with reduced primary energy consumption. This is wonderful. But how can come flattened scenario and negative growth? Because exactly implementation of new technologies, of emerging technologies that should be developed or adjusted to the large-scale application and their alternatives. And exactly these technologies can help us to reduce CO2 emissions with the base case to half, to 50%. And if it's stated now, at least 1/3 definitely can be reduced because of these technologies. Next slide, please. So what is usually modern trend associated with emerging technologies? Of course, it is renewable energy, but not renewable energy, classical use, purely renewable energy. It is implementation of renewable energy to the fossil fuel-based power generation systems. It is necessary for grid, for stabilization of grid. Energy storage options. Again, we return to nuclear energy. Different countries with different opinion about that. For example, Germany said we will not return to nuclear energy unless it will be new, completely new technologies developed and brought to the market. But for example, France already mentioned that they will continue with nuclear energy, and actually their idea to even more to move to nuclear energy because there are some advantages to use nuclear energy. And carbon capture and storage, this concept already people discussed it many years. There is successful practical application, but still it is quite expensive. So the problem with this concept, it is only the cost. Everything other is already well developed. And now I would like to show you some new concepts that can be part of these well-known concepts, mainly developed in Germany, to make this idea more prominent among international society. Next slide, please. So, a few more words about still about CO2 emissions. We know that all CO2 emissions in general, we need to divide to two groups, direct and indirect. Even renewable energies associated with very low, but nevertheless CO2 emissions, so-called indirect. Also, we need to distinguish between CO2 emissions emitted to the environment or all other emissions that can be recalculated as equivalent of CO2 emissions. It is different. It is different topics to discuss about emissions. Sometimes it is confusing, but nevertheless, all these emerging technologies contributed to both direct emissions, indirect emissions, and equivalent CO2 emissions. Next slide, please. Yeah. Now, regarding the storage. Left part, you can see all possible at present options for storage of mainly electrical energy. We can move from the very low capacity, which is left part of this diagram, to very high industrial capacity, right part of this diagram, but also very important, the time of the storage, from seconds, minutes, to days, week, and even months, which is very important for us, because if we discuss about large capacity, industrial capacity, definitely it will be very right part of this diagram, because we would like to have long-term storage, at least few days or weeks. It is already belongs to the category of long-term storage. And in the middle of this slide, you can see the table with very interesting information regarding the cost, capacity, and so on, but technological readiness level. Only small capacities storage available commercially. So it means battery storage. Everything which is large capacity, it is only demonstration or under development technology. And some of these technologies now really discussed as emerging technologies. For example, which is called CES, it is compressed energy storage. Mainly it is associated with wind energy. Also, we have H2, it is generation of hydrogen and storage of hydrogen as energy carrier. We have also CAES, it is cryogenic energy storage. And this diagram that you can see on top, it is exactly belongs to category of liquid energy storage. So when we have excess of electricity, we can take air from the environment, liquefy air, and liquefaction of air, it's very low temperature, it's so-called cryogenic temperature, store liquefied air, we can store it relative long period of time, and after that, through supplying very small amount of heat, maybe it is even heat stored within the liquefaction process, we can regasify air and generate electricity from that. So this is one of the technology that can be assigned to the emerging technologies with large scale storage. And why this technology is very interesting, maybe audience, you know that through if we have generation of electricity through wind energy, it is the low voltage electricity. And if we will use this intermediate liquid air storage and regasification, finally we can generate electricity with high voltage. It's already a different kind of electricity that can be used for industries. Next slide, please. Yeah, another technology is very interesting. This is purely developed in Germany, call it power to X. So if we have electricity, including renewable electricity, and we at one period of time, we have access of electricity, no need to store it. It makes sense to use this electricity for some conversion processes, generate chemical substances, and after that use these chemical substances to generate electricity or for some other applications. Next slide, please. Yeah, power to X concept was developed more than 10 years ago. First started as concept for storage of renewable energy, but now it is the concept of storage of excess electricity. So if we have base load and during the night we can produce a lot of electricity, we can do something with this electricity and stabilize the grid, because stabilization of electrical grid, it is very important issue. That's why we would like this grid to be smart. Next slide, please. Yeah, what means power to X? Power, it is electrical energy, exclusively electrical energy that will be generated using any way, including also renewable energy. two, it means that it will be conversion process, energy conversion process that required a lot of electrical energy for this conversion process, and X, it is new positive effect that we can generate out of that. The idea of power to X, it should be only large scale transformation. Power to X, small scale, doesn't make sense. Next slide, please. Yeah, and the basic idea of power to X. We have electricity, we can use water electrolysis, we will have hydrogen. And after that, with hydrogen, we can generate any other chemical substances. We can use hydrogen as a pure substance. We can produce ammonia, we can produce methanol, and we can produce synthetic methane. And I saw already somewhere in the chart, someone asked if we can use CO2 for production of fuels. Power to X, it is exactly this option. With an electrical energy using electrolysis, we will produce hydrogen. And after that, CO2 plus hydrogen, we can generate methane. And for example, ThyssenKrupp company said that power to X, it is a very good technology because can help to avoid battery storage, because electrical battery storage, we already mentioned, in large scale, this concept doesn't work. But if we have power to X, we don't need large scale battery storage. Next slide, please. Yeah, and I already mentioned that this concept is developed in Germany. It's a German concept, and still it is up to technological readiness level 6-7. We have some applications, but not full industrial scale application. And here on this slide, you can see how many publications, reports, and research exist in this field. Of course, Germany is leading because this concept is developed in Germany. This is just for the statistical data information. Next slide, please. Yeah, thank you. And my research group is also working in the field of power to X. We recently published the paper, and this is information from this paper. We exclusively for Germany, because prices of electricity very high, we evaluated for four options. What is better for energy? To produce hydrogen and liquefy hydrogen, and after deal with liquid hydrogen, to produce methanol, to produce ammonia, or to produce small amount of hydrogen and mix this with the natural gas. And all options, as you can see, production, distribution, emissions, safety, toxicity, so everything was included in the evaluation. And final conclusion was that for Germany, for the prices of electricity, methanol and ammonia quite comparable, and sometimes ammonia is the winner for Germany, but for each other country, conclusion can be different. So as you can see, this is one of the emerging technologies that can be used for the large scale application. Next slide, please. Yeah, we're coming to the conclusion, and we already mentioned all these advantages and disadvantages of these technologies. And mainly, we would like to achieve not only zero emission energy sector, entire production and consumption, but we also would like to have sustainable. So it means that it should be not only efficient, but also environmentally friendly and economically feasible. So next slide, and with next slide, I will tell you, thanks a lot for your attention.
Thank you very much, Tatiana. Sorry, there's an echo. Our next presenter is, just a second, is Dr. Joe Havemann, a scientist by education and in evolutionary developmental biology, and currently a trainer and consultant in openly scholarly communication research project management. She's also the co-founder and coordinator at Africa Archive, publishing platform to increase the discoverability of African research accomplishments. with a focus on digital tools for science and her label Access to Perspectives. She aims at strengthening global inclusive science communication and research management through the adoption of open science practices.
Thank you, Victoria. Okay, so basically the connection to Tatiana's presentation is mostly that we rely on energy and also connectivity as a second level of resource and infrastructure for the services that we provide with open science practices generally, and then open access publishing specifically, or more specifically. And what I'll be presenting today is a repository that we've built over 5 years now and are now transitioning towards Africa and on African hosted facilities. Let me share my screen to do that. So together with me on that slide, so you find my contacts and also Professor Madara Gertz. He's the CEO or the director of UbuntuNet Alliance, which is an NREN, a regional education and research network. So they provide connectivity, so basically provide digital infrastructure for research and education institutions in the whole of Southern and Eastern Africa. It's basically half the continent. And we're working now together to establish Africa Archive on the continent as Africa-hosted, African-owned repository for African research to be disseminated and to be made discoverable using digital infrastructure and international standards and services. So our mission is to make African research discoverable together. So it's all a collaboration with the theme of today's webinar, with SDG 17 to work together to achieve all of the SDGs. And we focus primarily on SDG 4, which deals with education and research and knowledge generation and dissemination. And the phrase that we just saw in English, you can also say in Swahili, because Madara Gertz is Kenyan. So, wacha tufanye utafiti wa Kiafrika kugundulika kwa pamoja. It's basically the same that you just heard in English. I'm mentioning that because multilingualism is also important to us, and we feel that, or I personally also as a trainer for open science communication, feel that to be able to consume but also produce knowledge as a researcher or as a recipient of the knowledge generation in your own language is essential. And therefore we allow submissions by researchers in any language, primarily the ones spoken on the continent. Yeah, and also our website, or the front page for now, is accessible through the languages that Google Translate supports that are spoken on the continent, which includes English, French, Arabic, and Portuguese, but also many traditional African languages. So that's our main page. So we're building solutions that are tech-based and rely on the internet and therefore also energy supply for the remaining challenges that African research keeps facing, which is, for one, language barriers, the digital visibility of African scholarly output. So the bulk of the research accomplishments is not discoverable because there is no assignment of digital features which then enable the detection by search engines such as Google Scholar to display the results. There's also a general complaint by international research consortia and associations that African scholars are underrepresented, and that's due to the low visibility and as well as restricted access to research funding. And by increasing discoverability, we're aiming towards providing now these benefits that we mentioned here to researchers, publishers, and libraries in Africa alike, including reputation building, networking and capacity building, networking opportunities and capacity building. So infrastructure-wise and also conceptually. So we provide trainings and webinars on publishing using digital means and services, and all of that to, again, just increase discoverability of research output, primarily through the indexing of scholarly content coming from Africa in international international repositories, or according to international publishing standards, by assigning the so-called DOIs, digital object identifiers, which enable discoverability digitally, and open licensing to ensure ownership of the research accomplishments to remain with the African scholarly community, or in particular the originating authors. So here you see a snapshot of like our submission portal, so to say, that you find on the website. We have so far, we launched in 2018, and we have launched with the Open Science Framework, which is located in the United States and run by the Center for Open Science, and then diversified using also PubHub, Figshare, Zenodo, yeah, and all of these are of highest digital standard and international publishing standards. And we just ensure quality by having in place a moderation process, and thereby encourage researchers to submit their work, and also providing the opportunity to make it digitally discoverable. So here you see a bit of a schema. So the left-hand side is the remotely hosted services that we have worked with so far and continue to work with. But now we're setting up a centrally hosted repository, which is UbuntuNet Alliance is hosted in Malawi, and we're using their servers, which are located in Zambia and Uganda, to set up open source technology or software to now build, and that's basically ready to go. So we will launch the campaigns for adoption in early 24. And then expand into other open source services to build capacity across the continent to allow for diversity also of digital infrastructure. And because many of these systems are already in place to some extent, but because of the institutional readiness or the lack thereof, and the gaps in the infrastructure development in many parts of the continent, we are now providing services for the institutions to leverage, to work with us, to tap into newest technologies and update the ones they already have, and developing and sharing workflows that are easy to manage, not to exhaust the budgets and resources that are accessible and available. So I've just launched last month in Uganda, the new platform. And I just want to share a word or two about Diamond Open Access. Those of you who are familiar with the publishing processes and open access generally, there's now a misconception that Gold Open Access is the only way forward, where now researchers have to pay to publish. Before, there was a majority of research output where readers had to pay to read. And then there was, or it still is, ongoing movement on the call for liberating research outputs, and Diamond Open Access is not charging the readers nor the submitting researchers for publishing, but there's other means of sponsorship and financial support to continue the service, or to maintain the services. It's just highly underused. So we want to advocate for the adoption of Diamond Open Access. And it's not, I think, like personally as a biologist by training, as was pointed out by Victoria, I believe in the system, or I don't know if it's a system, I believe in diversity, generally speaking, because diversity just allows for a lot of resilience in any system. technologically as well as biologically. So in any ecosystem, if you have a diversity of animal and plant species, any drama or scenario can happen. The majority of the living organisms will still survive. If you rely on only a few or just one, as we see with crop and agriculture, it's a very fragile system, even if it produces a lot of yield, but then you just need one drought and the whole harvest is spoiled. So diversity is key. So therefore we want to strengthen diamond open access, but still, but not necessarily abolish other forms of open access and publishing workflows, because it's always good to have a mix of practitioners, and also to be agile and to be responsive to whatever happens with economies as we move forward in time as a global society. Okay, so there's various institutions and organizations and workflows already in place, which can be leveraged upon to support diamond open access in Africa in particular, but also on a global scale. And we are currently on a grant by ORCID, which is one of the key digital infrastructures for scholarship and publishing and for researcher support, which allows us to also build capacity in the region for the adoption of open science practices and persistent identifiers such as DOIs, ORCID, and ROAR for institutions. And we have an ongoing webinar series on open science to which you are quarterly invited. You'll find it on our website, africarchive.org, and then there's a tab for webinars where you can find the upcoming featured organizations and services that we have lined up into 24. And we have still 3, I think, this year. So just to conclude, these are the scholarly principles and recommendations we base our work on, which is all, we work closely also with the UNESCO office in Paris that specialize or that has developed the globally inclusive recommendations on open science. And these are our partners, project funders. And you can reach out to us anytime to let us know if you have any questions or see opportunities to work together to make African research more discoverable, but also research globally inclusive for publishing. Thank you.
Thank you, Jo. That was wonderful. I like how you're shifting the perspective from local, national to more global, inclusive, and not just shifting, but facilitating infrastructurally those that cannot afford to put the research at the front of the global audience. So thank you. And our last presentation is from our partner, Zendy. Monica, who is head of marketing, will give us an overview how collaboration between key stakeholders in open access can support the dissemination of content in underserved communities. Monica, the floor is yours.
Thank you so much, Victoria. And thank you also to Jo and Tatiana for those interesting presentations. Just one moment while I adjust. Victoria, we can move to the next slide. Thank you. Welcome, everybody. Thank you so much for joining this webinar. It's a pleasure to be here and to talk about all things accessibility, discoverability, and also introduce you to Zendy. So for those who have not come across Zendy before, Zendy is an AI-powered research library. It was founded in 2019 with a mission to make scholarly literature more affordable and more accessible. Fast forward to today, Zendy hosts over 400,000 users from 200 countries and territories around the world. And largely, our user profiles include students, researchers, and professionals. We work very closely with world-class publishers, such as the wonderful team at IntechOpen, to really increase the discoverability and accessibility of open access content. Now, in regions where open access is either not available or as readily accessible, we do form partnerships to make paid content more affordable. We do this through our affordable access plan, and this gives our users a legal alternative to pirated content. Next slide, please. Thank you. Okay, so let's talk about partnerships for accessibility and discoverability. So the key ways that we contribute to accessibility and discoverability includes expanding our reach in underserved regions, the expansion of our OA catalog, and one example of that is also the inclusion of IntechOpen books on the Zendy platform, and also the discoverability of both open access and affordable access content via our channels. We work very closely with all stakeholders in the publishing spectrum, and this is important to us. Sorry, I just want to make sure, am I audible? Because I just saw a couple of comments.
I can hear you clearly, so.
Okay, sorry to those listeners who are having an issue with the audio. Hopefully we can rectify that. Okay, so going back to partnerships for accessibility and discoverability. So we expand the reach of OA content, we improve accessibility where it's needed most, and we accelerate the discovery of knowledge. Next slide, please. Okay, so how do we make content more discoverable? First and foremost, we work with publishers. This is one of the examples of how we make content discoverable. We partner with publishers to hold joint webinars. We do social media campaigns with publishers, and we also collaborate with them for conference proceedings. Another key way that we make content discoverable is that we have the ability to focus our marketing efforts in different regions based on the needs of a certain provider or publisher. For example, if there is a publisher or content provider who wants to reach a specific region, for example, Nigeria, we can help facilitate that through our platform and the reach that we have in those regions. We also work with publishers based on analytics that we generate from our user base. So an example of that is we may be able to collaborate with a publisher who wants to reach a niche audience who have a specific interest in a niche topic. And of course, we leverage the best technology to enhance discoverability. Technology is really sitting at the core of solving some of the accessibility and discoverability issues that currently exist. And we're hyper-focused right now on building a super easy to use platform that is impactful, both for publishers and also for end users who are essentially the readers of this research content. Next slide, please. Okay, so one of the key ways that we're using technology right now is harnessing the power of AI. So currently, of course, as many of you would know and are reading about, ease of use is becoming synonymous with the immeasurable capacity that AI has. This year, we've launched a range of tools that we've designed to facilitate a smooth discovery experience for our readers. Some of those tools include AI summarization, which generates an on-demand summary of very lengthy research papers that allows readers to streamline their literature review process and dissect large amounts of research in a shorter amount of time. We also have keyword highlighting, which allows users to highlight key concepts in research papers. And this really aids in discovery as it allows people to identify additional concepts to explore and then continue their research in that way. And last but not least, we have been working hard on a LLM model that is trained in-house with our own data. So that model can answer research questions about key concepts and then also recommend further reading for research papers that will help in the discovery of new research. And we really believe that this is going to be a pivotal tool that will help further accelerate discovery. In addition, with our LLM model, we can actually customize data sources to fit the needs of different institutions or corporations, should they want to have a model of their own that's customized with their content. Next slide, please. Okay, so this we think is super important because the analytics that we generate about our readers truly help us assess whether our efforts that we put into discoverability and accessibility are making an impact. What we can see through our data is a very large percentage of our readers come from the developing world. And a key part of our mission is to make content available and discoverable to readers outside of the established publishing world. Now, a lack of funding for these readers mean one of a few things. It means that perhaps they cannot attend a university or are attending a university which is chronically sort of funded in terms of their institutional budgets. Now, lack of funding also means that readers have to look at alternative access methods, and it can't go without saying that some of these methods include pirated websites. We're very aware of that, and the whole purpose of Zendy, especially in these regions, is to provide a trustworthy search platform which provides access to content in a legal and credible way. It's also worth noting, and this is something we've found interesting, is that we do have a growing audience of readers from developing countries. And an example of that could be the US. Some analytics we ran recently show us that we do have some readers who are in the US, but they're attending smaller institutions whereby they have limited or low quality access to library databases. So we can really see through our data that on a global scale, there is a quite significant issue related to accessibility and discoverability. And the work that we are doing today, we hope will have a very lasting impact on a sustainable tomorrow. And we truly believe in a world where equality of access is a real thing and not just a pipe dream. So no matter where you live, no matter where you work, no matter where you study, the future of Zendy is really to be a home where you can come and find the research you need for a more knowledgeable tomorrow. So I will conclude with those statements, and I thank you so much for your time. Looking forward to any questions you have, and I will paste a couple of links in the comment section so you can explore Zendy. Thank you.
Thank you, Monica. I would like to, I see that the chat and Q&A are very much active, but because we are running out of time, we will answer those questions that have not been answered already through email. All presentations and slides will be available on our webpage, and we will hand out the participation certificates to the participants as well. I think that I would like to add just one very important aspect that encompasses all presentations, and that is a call for responsible research and research integrity from the initial idea to publishing and responsibly reusing it. Once again, thank to all panelists for their wonderful presentations. I would like to conclude this webinar with a, it's not a punchline, but a mission, and that is we should constantly ask ourselves, are we doing enough in connecting all parties involved in the scholarly communication ecosystem in achieving the sustainability, and in our everyday activities we should ask ourselves, are we doing enough for equity and sustainability? Can we do better? Can we be more efficient in order to reach at least the majority of sustainable development goals, if not all, by 2030 and beyond? We should think even beyond. Thank you again for your time. It's been a real pleasure.
Thank you so much for having us, or me, and yeah, us. Is the video going to be shared?
Yes, it will be on our webpage, and we'll share it. We'll share the link with participants.
Nice, cool. Wow. Also.